Hey Learning Birds, this is Mr. Ozarka with another lesson brought to you by LearningBird.com. If you have any questions about the following video, you can email me at mrozarka@gmail.com. Alright, here we go. This is going to be a video about Boyle's Law. The thing about this law is that it's something that you've dealt with pretty much every single day and you probably didn't even know that there was a name for it.
A great way of demonstrating Boyle's Law is with an empty bottle of water. Now really this bottle isn't empty, it's filled with air. I know that because I can squeeze the bottle and feel the air coming out. So I know that there is air in here. Another thing we know about gases, like air, is that they fill up whatever container they are in. So basically the volume of the air in this bottle is equal to the volume that this water bottle can hold. Okay, Boyle's Law states that if you change the volume of a gas, so I have some gas in here, I'm going to change the volume of it, the pressure will inversely proportionally change because of that change in the volume. So as the volume goes down, the pressure will go up and vice versa. So what I'm going to do with this water bottle, so this is a good demonstration of Boyle's Law, is I'm going to change the volume of this air by squeezing the water bottle. So I'm just going to squeeze it like this. So I'm squeezing the water bottle right now. Now, how can I tell that the pressure of the gas increased? Well, if you feel the bottle, you can kind of feel that the pressure inside of it is increased. Another way you can do it is I can just simply open the bottle, and you can actually hear and feel the pressurized gas escape. So I'm going to do that again. I'm going to kind of expand this out here, seal the container. There's gas inside of it. I'm going to compress the gas. So the gas is being compressed now, and then I'm going to open it up, and you can kind of hear it come out. Now the opposite is also true. So if I increase the volume of the gas, the pressure will decrease. Okay, that's a little bit harder to show with a water bottle. So there's some other experiments that you can do as well to kind of prove that. So that's a demonstration of Boyle's Law.
Boyle's Law can also be explained mathematically by the following proportion. This basically reads in translation from math to English to say pressure is proportional to 1 over V, or you can say pressure is inversely proportional to V. Those mean the same thing. An important thing to consider with Boyle's Law is that all other variables remain constant, meaning that the temperature, amount of gas, and type of gas remains the same. The only change is in regards to the volume and the pressure for this law. Also, this only pertains to ideal gases, which will be explained in a later video. Let's look at this proportion a little more. Basically, this states that pressure P is inversely proportional to volume V. Another way of showing this is that the product of P and V before a volume change is equal to the product of P and V after a volume change. Basically, the product of P and V are always constant in a closed system. A simple problem showcasing Boyle's Law is as follows. If a gas at 25.0 degrees Celsius occupies 3.50 liters at a pressure of 1.00 atmosphere, what will be its volume at a pressure of 2.50 atmosphere? But first, let's write down the information that's given in the problem. Temperature T is equal to 25 degrees Celsius. The volume of the gas is 3.5 liters and has a pressure of 1.00 atmosphere. Since the pressure and volume are linked in time, I will label them both with the subscript of 1. The problem is looking for the volume, so we will write V sub 2 equals question mark to remind us that's what we're looking for. The pressure for that volume is 2.50 atmosphere, so they match with subscripts of 2. First thing to notice in the problem is that everything stays constant in the system except for pressure and volume. This is our sign to use Boyle's Law. I set up the equation from before for finding pressure and volume after a change in either of both of those variables. I substitute the values in for each variable and solve for V sub 2 to get 1.40 liters. So you might be thinking, who cares about Boyle's Law? Well, besides fully appreciating why balloons pop when you squeeze them too much, Boyle's Law is also utilized in piston engines and hydraulics. So that's a lesson on Boyle's Law. If you have any questions, let me know. And if you thought this lesson helped you, please be sure to click "This was helpful." For other great lessons, be sure to check out LearningBird.com.